Good afternoon, students. Today we're looking at finding the area of triangles, and we'll be trying to work out a formula to find the area of any triangle. We're going to start with the most easy triangle to calculate, and that would be a right angle triangle. If we watch the video on the left hand side, you'll be able to see we're going to try and calculate the area of the blue triangle. As I rotate that triangle around the center point of its side, you can see that that triangle forms a rectangle, and we already know how to find the area of a rectangle. We discussed that before. The area was the base times the height. So in order to find the area of this blue triangle, all we need to do is to find the area of the whole rectangle and divide that by 2 or multiply it by half, because you can see it takes up half the space of that rectangle. So if I look at the length of this rectangle, the base would be down here, and as you can see, that length is 4 units long. And if I look at the width of the rectangle, or the length, that is 6 units long. So the area of the rectangle is going to be 4 units multiplied by 6 units. But because we only want the area of the triangle, which is exactly half of that rectangle, we're going to multiply that by 1/2. So our area becomes 6 times 4 is 24, and half of that is 12. So it would be 12 square units. Another way of thinking about calculating the area of a right angle triangle, you can see on the left hand side, or right hand side here, we have our right angle there, is instead of rotating it around, is to draw another rectangle on the side. So we'll just watch this video so you can see what I mean. So we put in the rectangle there, and again you can still see that that right angle triangle is exactly half of the rectangle there. So again, if we were going to calculate the area, we would be calculating the area of the rectangle and then halving it, because the triangle is only half the rectangle. So area is equal to half multiplied by the area of the rectangle, which in this case is 9 units, multiplied by 6 units. And so half of 6 is 3, and 9 3s are 27. So that's 27 units squared, or square units. You can see in the background of these rectangles that they're actually put on squares, so you could count up the squares. So for example, on this side, if we counted up all these squares, there would be 9 across there and 6 across there, and 6 9s are 54 to fill up the rectangle, and of course half of those squares would be 27. So in summary, to work out a formula for our right angle triangle, if we have any right angle triangle, if we call this length the base and the height, it's actually the perpendicular height, that's the right angle, makes a right angle with the base. So we're looking at those two sides. We could make another rectangle out of this, and so it would be half of that rectangle. So in general, the formula would be area is the area of the rectangle, which is the base multiplied by the height, but it's only half of it, so it's a half multiplied the base by the height. We're now going to look at finding the area of acute angle triangles. So if you can see in the diagram in the left hand side, I have the right angle triangle again in which is half that rectangle. But what if that right angle triangle is not right angled? I'll just move it there. So there we have, with the area of the blue triangle now, it's no longer a right angle triangle. It is now an acute angle triangle. So we're looking to find the area of that blue triangle. Well, you can see if we look at where the perpendicular height is, notice that I'm looking at the height of the triangle from the top vertex to the base where it makes a right angle. So notice that the height that I'm talking about of that triangle is actually the height that fits in the rectangle, which is what's called the perpendicular height. So it's the height from the vertex to the opposite side perpendicular to it. So I'm going to call that H for height, keeping in mind that height is not one of the sides of the rectangle. And I'll keep the side, the bottom part, and we'll keep calling that the base. So again, if we have a look at breaking up this triangle, if I could break it up into 2 areas, I could break it up into this area where we can see the triangle takes up half the space of that rectangle, and I could break the other part of the triangle into this area, and we can see that again it takes up half of the space of this rectangle here. So if we add those two together, again, this triangle is going to take up half the space of each of those rectangles, so it'll take up half the space of the whole rectangle. So again, it's a matter of finding the area of the rectangle surrounding it and halving it. So in this case, the area is going to be equal to a half multiplied by the base length, which is 9, multiplied by the perpendicular height, which is 6. Remember, that is not part of the triangle. So again, that becomes 27 units squared. Notice that the area is the same as the right angle triangle we had before. You can see by moving the triangle so it's not right angled, it still takes up half the space of the surrounding rectangle. So far in general, our formula still holds. So the area of a triangle is a half multiplied by the base length multiplied by the perpendicular height. But remember, that perpendicular height is not one of the sides of the triangle. It's the height from the one vertex to the opposite side at a perpendicular angle, unless it's a right angle triangle where the opposite side is perpendicular anyway. So we're going to now look at finding the area of an obtuse angle triangle if we're only given the shorter side. So for example, if this is the triangle we were to find the area of, we may be only given this base side here, and let's say we would say the base is equal to 6. To find the area of this triangle, we're going to have to make the height outside the triangle. You'll see when I do, the strategy I'm going to use to find the area inside here is to create a bigger triangle, extending this line that's 6 units long, and dropping a line down from the vertex that's at right angles to that extended line. So the idea is I'm going to find, if I give these names, if this big triangle is now ABC, I'm going to find the area of triangle ABC, and then if I call this one D, I'm going to find the area of triangle ACD. So if I subtract those, what I will be left with is the area inside, or the area of this triangle here. So let's start off. So the area of the large triangle, remember the large triangle here is a right angle triangle, so it's a half times the base. Now the base distance across here is 6, but we need to know this distance here. So let's say they give us this distance and it's 2. So our base length is going to be 8 units long, and our height, let's say they give us that and they tell us it's 4. So our height of the bigger triangle is half times 8 times 4, which is 16 units squared, or square units. The area of the smaller triangle now, again, it is also a right angle triangle, which we know how to work out the area of. So it's a half times the base, which is 2, times the height, perpendicular height, which is 4, and so we get 4 square units. So the area that we're looking for inside of here has to be the big area of the big triangle minus this area here, and that will leave us with the area of the triangle we're looking for. So if we subtract those two numbers, we find the area is equal to 16 take away 4, which is 12 square units. So let's see if the formula works the same for the obtuse angle triangle as the right angle triangle. So we'll start off again with my triangle that I'm trying to find the area of, and we'll call that distance the base of the triangle. Now I'm going to call the height that line that we drew before, it coming down and meeting this extended line at right angles. So that's going to be the height. Notice that the height is outside of the original triangle. So here's our height. It's not a side of the triangle, it's not even inside the triangle. So again, what we're going to do is we're going to label this triangle, so we'll call it A, B and C. I'm going to call it, we know the distance from here to here is the base of the triangle, which we're going to call B. We'll call this extended distance X. So again, the idea is to subtract the larger triangle from the smaller triangle and see what we get. So the large triangle, large right angle triangle, has area a half times the base. Now the base length is this length here, which is X plus B, multiplied by the height of that triangle, which is H. So that works out to be a half HX plus a half BH. Now the smaller triangle has area, it's a right angle triangle, so again it's a half times the base length of that smaller triangle is X times the perpendicular height of that triangle is H. So that's a half XH. So to find the area of the triangle we're looking at, we subtract the bigger triangle from the smaller triangle, and which will leave us with this area here. So you can see subtracting these two things gives us a half, or this thing here, 1/2 hx, the big one, plus a half bh, minus the smaller one, which is this one here, 1/2 xh. And you can see we've got a half xh, take away a half xh, so the area is left with is a half times the base times the height. So the formula works again for an obtuse angle triangle. It's still a formula for a triangle is a half the base times the height. But remember, in an obtuse angle triangle, if you're only given the shorter side, the height may actually lie outside of the triangle. Just to make this clear, you can see this movie that I've added in. When we rearrange this obtuse angle triangle, it will form a rectangle just like the other ones, but you'll notice that the height AL becomes the height, which lies inside, or in this case, you'll see be outside the triangle. So let's watch this movie and see where the height is. So as we're rearranging it into a rectangle, you can see it's still the height of the rectangle, but that height may not necessarily lie inside the rectangle, it may be outside. So, in summary, we know that the area of a triangle is always 1/2 times the base of the triangle times the height. But remember, it's always the perpendicular height, the height of the triangle, which in the case of a right angle triangle is one of the sides. In the case of an acute angle triangle, it is the perpendicular height is not one of the sides. And in an obtuse angle triangle, the perpendicular height may not even lie inside the triangle, it might be on the outside. Let's try some examples. So here are some examples of 4 triangles, questions A, B, C and D. Why don't you pause the video and see if you can find the area, and then restart the video again to see if your answers are correct. So pause your video now, and when you restart, the answers for the area will be underneath. And so the answers are now appearing underneath. I hope you did well.